Hello student, let's try to understand a problem student. In an octahedral crystal field, draw the figure to show the splitting of d orbitals. So how the d orbital is split student in octahedral we have to understand. See the direction of ligands approaching student. In the octahedral, this is the octahedral complex student. If you are making this one, this is the octahedral complex, right student? But here the important things which we have to note student, that ligand is approaching from which direction? From the axis student. These are the approaching of the ligands. Keep in mind. Here the ligands are approaching the orbital student. Can you see this? So in an isolated gaseous state, all the 5d orbital of the central metal ion are degenerate initially. The ligands from the spherical field of the negative charge around the metal. In the field, the energy of all the 5d orbital will increase due to the repulsion between the electrons and metal and the ligand. So initially what is happening student, here this is the degenerate orbital, but when the ligands are approaching, the average energy gone high student, average energy of the d orbital in its spherical crystal gets increased student. Now step number 2 you see student, the ligands are approaching the central metal in actual bond direction. To illustrate this, let us consider an octahedral field in which the central metal ion is located at the origin and the 6 ligands are coming from the plus x minus x plus y minus y plus z minus z direction as shown below. H shown in the figure, the orbitals lying along the axis dx square minus y square dz square orbitals will experience a strong repulsion and reach in energy to a greater extent than the orbital with lobes directed between the axis, that is dx y dy z and dzx. Thus, the degenerate d orbital now is split into two sets and the process is called crystal field splitting. Okay, so when the ligands is approaching more closer student, because of they are coming in the some orbitals are coming on their way student, like here if you say dx square minus y square, so what are the lobes are the along the axis student, lobes are along the axis. So student, in the octahedral complexes, ligands are also going to approach from where student? From the axis only. So those orbital which are there along the axis, they will feel the repulsion. So here the energy will get increased student. Up to this point, the complex formation would not favored. However, when the ligands approaches further, there will be attraction between the negative charge electron and the positively charged metal ion. That result in net decrease in energy. This decrease in energy is driving force for the complex formation. There will be decrease in energy, that will be the driving force for the complex formation. During crystal field splitting in octahedral field, in order to maintain the average energy of the orbital by various centers constant, the energy of the orbital dx square dy z represent Eg, not the T2g. Eg orbital will increase by 3 by 5, while that of the other 3 orbital dxy dy j represented by the T2g student orbital decrease by 2 by 5. Here delta naught represent crystal field splitting energy in the octahedral complexes. So student, if you see this is the delta, this line is represented delta. How many it is? Total orbital are 5. So decrease less than the midpoint student. How much? That is minus 2 total orbital 5 delta naught. How much it? This is the down. This is going to be down. What is the up student? More than 3 orbital. So it plus 3 by 5 delta naught. So this is crystal field splitting energy student. In case of a strong ligand student, this energy will be high, and in case of weak ligand, the energy will be low. Thank you very much for watching.